All right, so the things we need, if we want to read from a file or write to a file, we have to include a new header file. We have to include fstream, which stands for file stream. Now, there are two different ways to define a file stream. You can either do it in 2 lines or 1 line, depending on what you prefer. So you can do it in 2 lines. For example, here it says you can create an input stream by you write the command ifstream data in and put a semicolon. And then later on, you need to connect that to the file. So you would go down here and you would go data in dot open parenthesis quote sample dot dat ios in. Or the way we normally do it is down at the bottom. We create the data stream and we connect it to the file all in one command. So if you want to create a input stream, you can do it in one command. Ifstream data in, give it your file name inside quotes, ios in. Or if you want an output stream, it's output fstream data out, put your file name in quotes, ios out. Okay, so that's the way I'm going to traditionally do it. I'm going to do it in 1 line. So what does this do? What does this command right here do? Ifstream data in sample data ios in. That does 2 things. Jeremy. It's telling it what file to pull from. So it's telling you we're going to pull data from the file called sample.dat. And you can either use .dat files or .txt. Those are your 2 choices. I don't know why I put .dat in all of my file in all this, because I'm going to use .txt in all my examples. So this does 2 things. One, it tells the computer data will come from sample.dat. So it tells the computer, you need to go look for that file, make sure it's in the right place, make sure you can use it. And the other thing that it does is it creates this command called data in. And what's this command data in going to do? It's going to be read. It's going to be the equivalent to our cin, except instead of having to type something in from the keyboard, it will read items from the file itself. So the second thing it does is it creates the command data in. And this command is like cin that we normally use, except instead of reading from the keyboard, it will read from the file. Okay. This command, offstream data out, output.dat, ios out, is almost exactly the same thing. It creates a file called output.dat, and it tells the computer you're going to write information into that file. And then it creates this command data out. What's data out going to be like? It'll be just like cout. It'll have all the properties of cout. So you can use it exactly like you would a cout command. Everything you can do with cout, you can do with data out. The only difference is when you use data out, things will not show up on the screen. Rather, things will be written into the file. Okay? It will create, if you try to read data from a file that doesn't exist, that's a good question. What do you think is going to happen?
Well, I mean, it can either crash or give you some sort of error, like build and stuff.
I think it does an even weirder thing. No, you're right. It's going to crash. It'll say that it can't find the file and it'll crash. We can try that in a minute just to make sure. But I'm pretty sure that's what it's going to do. It's going to say it can't find the file. The program will crash because the file doesn't exist. However, when you're doing output, if the output file does not exist, the computer will create the output file and write to it at the same time. Okay. What's that? Correct. So ifstream, this is an input file you're going to be reading from this file. OFstream stands for output file you're going to be writing to that file. And then an fstream, which we will not use in this class, but you could have fstreams, which allow you to both input and output at the same time. And I've never played with those, so I honestly don't know how they work. I don't know how they read the data and write the data and don't overwrite the data that you had written. So one of these days I'm going to play with that and see how it works. But I know such a thing exists. You can have one file that you read from and write from at the same time. It's kind of a weird idea. Well, it kind of makes sense. I mean, if you're manipulating your data somehow, you want to read in your data, change it, and then put it back into the same file maybe. But I've never played with that, so I'm not actually sure how that works. Listen. Yeah, I mean, you can do any calculation. Any calculation that you can do in C++, you can do, and so you could read some data. Maybe you want to, I don't know, round all your data to 2 decimal places and then write it back to the original file, something along those lines. Other questions? All right, then. So let's write some programs. First one says, code a program that will read 4 values that represent the number of gallons of gas needed to fill a gas tank. Then it's going to read the starting mileage, the ending mileage, and finally it's going to compute the gas mileage. All right, so bring the computer back to life here. All right, so on my memory stick is in the E drive, I have a file called in.mpg.txt. And so you can see what's in this file. That's how much, these first 4 are how much gas it took to fill the tank. So you stopped 4 times and you filled your tank and you kept track. This is the mileage on your vehicle when you started keeping track, and this is the mileage on your vehicle when you were done keeping track. So how do you figure out your gas mileage if you have how much it took to fill your tank, your starting mileage, and your ending mileage? N minus start divided by total number of gallons. All right, so that's going to be our math in the end. All right. But it is helpful to have an idea what the data file looks like. There's what the data file looks like. And truthfully, extra spaces wouldn't matter. The computer will just ignore extra spaces. I could put returns in here. It wouldn't matter. The computer would just ignore returns also. So it really doesn't matter how your data is formatted. Your data can be pretty ugly. Not this one looks pretty nice and clean, actually. It can be pretty ugly. The computer will still read it. All right, so if we're going to read from a file, we still want to include the IO stream because that still lets us use cin and cout. We might want to use that in the program. But I need to include something else. What do I need to include? Fstream. So I need to include Fstream. All right, and we still using namespace std. Now, normally, I like to create my file streams right here. I create them before the void main. The reason for that, in the very near future, we're going to start talking about functions. Functions are like little subprograms. If I declare my file streams right here, then my file streams will work everywhere. They'll work in my main and they'll work in all my little subprograms. If I create my file stream in here, my file stream will only work inside the main. It will not work inside my little subprograms. So I might want to be reading and writing inside my little subprograms. So it's in your best interest to create your file streams up here. All right, so I need an input file stream. So if we go back to our coding here, for an input, I'm going to input, so I need an if stream, and then I need to give it a name. So I'm going to have if stream. What do we want to call it? A command like cin. Data in. Okay, data in is fine. I like to use read, but we'll use data in because that's what I had on the sheet there. Data in. All right. Then we need a round bracket, quotes with our file name. When I put that under the camera, you can't see it, can you? It doesn't help you much. Quote, file name. My file name was e:/in mpg.text. And I put the e: because it's on the memory stick. And it's going to be to your advantage to put things on a memory stick. It's going to be easier that way. Comma, iOS, : this is an input stream, so I put input, and then a semicolon.
On the note sheet in the data in, you have the I capitalized container. Should it be lowercase?
It doesn't matter. You're creating this name, so it's whatever name you give it. So the D doesn't even need to be capitalized either. So maybe you just use DN instead of CN. Normally we use CN. Why not DN for data in? Like I say, I typically use the word read to read from a file, but we'll use data in for that. Now, for this program, am I going to want to have my answers show up on the screen, or do I want to write my answers to a file? Let's do a file. Let's do both. All right, we'll do both. If I'm going to write to a file, then I need to create a output file stream. So that's an OF stream. And then I need to give it a name. Data out. Okay. Data. There's my D. There it is. Data out. Quote. I need to decide the name of the file that I want to write to. Output.txt. Do I want to write it to my memory stick, or do I want to write it to the default directory? It's a lot easier to write it to your memory stick, and then it's easier to find the file. So I'm going to write it to the E drive, e:/output.txt, comma, iOS : this is an output stream. All right, so what this gives me a command called data in that's going to work just like cin, except it's going to read from a file. And this also gives me a command called data out, which is going to work just like cout, except it will write to the file instead of the screen. All right, so we've got our input and output streams created. Now we need to write our program. So we're reading in, if you remember what we're doing here, we're reading in 4 mileages. No, we're reading in 4 amounts of gallons. And then we're reading in a starting mileage and an ending mileage. And we want to take ending mileage minus starting mileage and divide by total number of gallons when we get all done. So what kind of variables do I need? Okay, so what kind of variable is that? Int, float, double? I would use a float, although if you remember what the data looked like, it was actually an int, but I would use a float just to be sure. So float. They might. The gallons were in tenths. The mileage were actually integers. But it's probably, quite often when you're writing a program, you actually don't even know what the data looks like. So it's probably a good idea to use floats if you're not sure anyway, just then you're safe. So we're going to have a float called start miles and another one called end miles. Okay. Our starting mileage and our ending mileage. What else do we need? Gallons of gas. Is that total gallons of gas, or is that just an individual one that we're reading in? Is what?
We have
Yes.
to read them all in first. So
All right, so we have to read them all in first. That's correct.
we can find all.
All right, so this becomes a question. Do you want to create 4 individual variables to read each 4 mileage? Or do you want to create 1 variable, read it 4 times, and then just add them up? Option B, I would agree with option B. I prefer to create fewer variables whenever I can. So I would create 2 more float variables. One of them would be called gallons, and then total gallons. In total gallons, I'm going to be adding stuff to it, so I better initialize that. I'm going to start it at 0. So you could create a gallons 1, a gallons 2, a gallons 3, a gallons 4, and add each one, read each one individually. Again, my personal opinion is I prefer to create fewer variables whenever I can. All right. See out. I want to give some directions to the user. What should I tell the user? I should tell the user the input file so they know what file they should have to use. What else should I tell the user? What the program does, and I should also tell them what the output file is so they know where to look for it. All right, so this program will read 4 mileages, 4 gas fill-ups. That's not very good English, but look at that. Gas fill-ups and starting mileage, mileage, and ending mileage from the file in mpg, yes, that mpg.txt. It will compute gas mileage and output it to output.txt. All right, so it's a very good idea within the directions to be very clear to the user to tell them what files they should have and what files they're going to get when they're done. That way they know what to look for. Make sure they have. All right, so I should have documented this up here too, but I'm just going to, the document stuff, I'm just going to put document symbols there and you would fill it in. All right, so we told the user what's going to happen. Now what? What's that? No, they're not actually going to input anything. The computer's just going to read it from the file. So it's going to happen automatically. They're not going to have to do anything. So we better start reading the file, right? Except we need to read in this gallons thing 4 times, don't we? So we need a while loop. Do we want a while loop or a do while loop? It doesn't really matter. I would probably use a do while loop because I definitely want it to run at least once. So I might as well use a do while loop. So I think I would use a do loop. Do while. Do loop to read in the gallon values. Okay, so I need to read in the first gallon value. To do that, I use data in gallons. So you see how you use that exactly like CIM. Exact same notation. Data in, the double greater than, and then the gallons. Just like you would CIM. And then I need to keep track of my total, right? So total gallons. Oh, you want to use the plus equals notation? All right, I like that one. Okay. So total gallons plus equals gallons, which means I take my gallons, my total gallons, and I add my gallons, and I keep a running total. Now I'm missing something though. What am I missing? I need something to control my do while loop, don't I? Or right now it's an infinite loop. It's going to try to reach forever, isn't it? So I need something to control it. I need something to tell it when to stop. I need a count. And so I need to count when it reads 4 things, stop. So that sounds like I need another variable, don't I? So I need an int count. Started at 0. Oops. And this is just a loop control variable. That's what it's going to be used for. All right, so I think I would go right here, count, see out count, plus plus. So I read the first thing, I kept track of my total, and now I counted that I've read the first thing. So when am I going to tell this loop to stop? While count is less than 4.
No, not in a do while. So it's going to automatically run on the first time, which is 0.
Correct. So that I tried to catch some of you, and I think I did. I started my count at 0. So when it starts at 0, it reads the first data value. Then it goes to 1. When it's at 1, it reads the second one. When it's at 2, it reads the third one. When it's at 3, it reads the fourth one, and then it should stop, shouldn't it? All right, so be careful on that. I started count at 0, which means I need less than 4. If I had started count at 1, then I would want less than or equal to 4. So be careful of how you start your count loops, your counters there. It makes a difference on when you tell it to end. All right, so we have given directions to the user, and we have read in all of the gallon amounts. Now what do we do? We're not ready to math yet. We need to read in the mileage, don't we? We need to read the starting mileage and the ending mileage. So how are we going to do that? Data in. All right, so we're going to have data in, start miles, end miles, if I can spell it correctly. So again, just like with cin we can tell the computer to read more than one thing at a time. With data in, we can do the exact same thing. We can tell it, read the first value, then read the next value.
So it's still looking for the spaces.
It will, right, it looks for either spaces in between values or carriage returns, one or the other. All right, so again, I should probably document reads mileage values. Okay, now I think we have everything we need, don't we? We have our total number of gallons, we have our start miles, we have our end miles. I think we're ready to tell the person how good their car is. So what would we do? Divided by total gallons, and what are we going to do with that? Output it. All right, so we would do a cout.
Well, we should output it to both detection and TCO, because then the user can see it in the program, but it's supposed to output it to output that.
I agree with you completely, and that's exactly what I'm going to do. I'm going to output it on the screen so that the user knows the program did something. Otherwise, it's just going to run and say press any key to continue, and that would be kind of weird. And I'm going to output it to the file so it will dump to the file, and we can look at it in the file to make sure that's working.
So, when you pull data from a file, how does the program know your range of data from the file?
The program does not.
So every data in has to be in order.
Correct.
So you could have, in this case, you could have gallons in order and then miles in order.
Correct. So for this program, I need to make sure the data is in the right order. I need to make sure that it has the 4 gallons things first, then the starting mileage, then the ending mileage.
What if we're trying to make it a user-friendly file, we're making columns?
It wouldn't matter if it was columns. The computer is going to take the first line and read it left to right. It sees a carriage return, it'll go to the next line and read it left to right. It reads left to right, top to bottom. So sometimes it's very important to make sure that you know how the format of the data. Because if you don't know what the data looks like, you might not be reading what you think you're reading. So in this case, that's why I showed the data file at the beginning, to show that it has the 4 gallons, the starting mileage, the ending mileage. So when the computer reads it, we need to make sure that we read them in that order. If I read them in the wrong order, I'm going to have bad information. I won't get the right answer. Makes me sad. All right, anyway. So we're going to see out your average mileage is, and then you said I needed to do end miles minus start miles. Oops. Wrong thing there. Start miles divided by total gallons. Is it not? Something. All right, and then, so that's going to print to the screen. I'm just going to copy that line and paste it. I don't know why this program does this. It's the first time to copy. It's very slow. There it is. The only difference is, instead of using the word cout, I want to use the command data out. And again, notice data out works just like cout. You use the less than symbols. You can put things in quote for text. You can do more than one thing. You can do formulas, so on and so forth. All right, let's run it and see what it does. Hope it works right. Thinking. This says the program will read 4 gas fill-ups and starting mileage and ending mileage from the file in mpg.txt. It will compute gas mileage and output it to output.txt. Your average mileage is 32.0612. I suppose I should have put miles per gallon on the end of that. I should have given units, but I didn't. And an end line would have been a nice thing to do too. Now, if we go back to our E drive, we will now see a file called output.txt. And there it is. Your average mileage is 32.0612. You want to drive that car?
Well, that's a Prius.
That's the Prius. It's certainly not my truck. I don't know. I think I just made up those numbers. I don't think it was real data from anything. I think I just made up those mileage. But
For all you know, it took you back 200 miles again.
Well, no, I did run it in advance to make sure my numbers were realistic, that I didn't get 200 miles per gallon. In fact, I randomly made these numbers up last night, and then I quickly wrote this program and ran it, and it was saying something like 8 miles per gallon. So I just added more miles to the end to change my data to make it a better number. You get 8. I get about 16 with mine, but it's not very good. Questions on that? So notice writing to the file is kind of nice because it doesn't put the press any key to continue, so you don't have to worry about an end line there. And when you dump all your stuff to here, of course, you can just print directly from here. You don't have to copy and paste your stuff into Word, although of course you can to put it all into one file if you want to have your output and your coding all in one file. Questions? Questions on writing to a file or reading from a file? it will overwrite it. So let me show you that. Let's change this. Let's change the mileage, which will change our average. So we'll take off 10,000 miles. So I save my data. If I run the program again, it runs. Now I'm only getting 11 miles per gallon. But if I go back to my output.txt, that's all it says. So every time you run your program, it's going to overwrite that file completely. It's going to erase it, put in all new stuff. Well, it will not write to a Word file. It will only write to a .txt. You can open a .txt with Word, but typically I open it with, if you just double click on it, by default it opens with Notepad. So you could then, edit, copy it, and paste it into a Word file if you wanted to. Kaylee, did you have a question? There's only two types of files you can use. .dat, which stands for data, or .txt, which stands for text. A data file? I could save this file itself as a data. I don't know what kind of software actually writes a file that has a code called .dat. I'm not sure. I think you could take Excel maybe and convert it into a .txt or a data. Let's look. If I have Excel, save as. It has lots of options. Yes, you want, I think if you're going to use Excel, I think you want to save it as text msdos.txt. I think is the one you want. If not, it'll screw up. But I don't see .dat here. So I'm not sure what uses .dat, but I know C++ can read .dat. All right, so then we asked, what if the file doesn't exist that you're trying to read from? So let's just rename this file. We'll call it, and we'll just put a number there at the end. We'll just rename it. And let's go back and try running our program again. So it'll run. Couldn't find the file. So what did it read in? Who knows? It didn't read anything. The file wasn't there.
I guess that makes sense, because then you can do if whatever return equals -0, if the message sent on that file is score, you can make that.
Also, if you did 0 miles.
If you got 0 miles for the we got -0. It's even worse. Even worse. So that's an interesting thing. If the file doesn't exist, the program will run and it will give you an answer. Your answer doesn't mean anything, but it will run and give you an answer. No, that doesn't really matter. I mean, it tried to read in all the values. Just for fun, let's put in a cout gallons. So every time it reads a gallon, it should print it to the screen. Let's just see what it prints and see what it thinks it's reading. But it's not reading anything. What does it think it's reading? No, it read in -1.0737 times 10 to the 8th. Of course. And it read it 4 times.
Wonder what file it's accessing. Well, how do numbers?
It's not accessing a file. What it's actually doing is it's accessing a memory location. So this is a pointer. So this value is the value that was in the memory location that it's accessing for whatever it was used for last. Well, I don't know what the memory location is, so I don't know how to delete it. Yeah, let's find it. So that's what it does. And C will do that, unfortunately. If it can't find the data, it says, well, I'll just look in the memory location that I think I should look in, and I'll come up with a number, and I'll give it to you. There you go. Nice number.
That's why we say that even if you delete a file, it can still be recovered, is because there's still something there so it's overwritten.
Correct. If you delete a file, it is still on your computer until that memory spot is overwritten. And even then, there are shadows that people with really good cyber technology can still get your data. So if you think you deleted that email and you think it's gone, and it's something that you shouldn't have been doing, it can probably be found.
Big companies, they get computers, will actually send the hard drives out to projects.
Yes, and I've done that anytime I've had a personal computer that I no longer use. I pull the hard drive out of it and take a sledgehammer to it because it's got my credit card information on it. I mean, if you use that computer to buy stuff online, it's got your credit card information. I use my computer to do my taxes, so it's got my social security number on it. So I literally take that hard drive and I take a sledgehammer to it and I crush it.
Is it possible to do a thing out with cat videos instead? Like, where instead of taking sledgehammer, could you overwrite everything with cat videos?
There's actually a program out there that'll if you want to wipe a hard drive or a flash drive, it will just overwrite the whole thing. You can just want to random ones and zeros.
The other option is to get yourself a great big magnet and put your hard drive next to a magnet, and that'll wipe it
Just
too.
take two of those USB magnets and put your
Yeah.
hard drive right
So,
between.
does that technique still work with solid state disks?
I don't know. That's an excellent question. I don't think magnets work with solid state disks. What's that?
Fireworks, there's like a process.
Fire will work, yes, if you melt it, that'll...
There's like a process that the government uses to do something like an IDDS, where like they wipe it, then they download it with the random ones here, and they do it like 7 times, then they dip it in a chemical composite.
So the government's very serious about wiping their data. Except for when the government officials use personal email accounts. Well, it's not only Hillary. If you look at the whole Trump administration is under fire for that right now, too. They're doing the exact same thing that they yelled at her for doing for months, which just kind of cracks me up. That neither party can do it right, which is just funny to me. All right, now let's save this program. All right, yes. I post them to Blackboard. Yeah, they're not very useful to me. Yeah, if you go to Blackboard, all the programs are saved, and all the videos that I record, those are saved. Those are there too. Yeah, they're all there. All right, let's start this other program. We might not have time to finish it today. Now we'll finish it next time. Code a program that will read integers from a file called integers.txt and write their product to a file called product.txt. All right. Well, let's see. I'm going to delete most of this because I don't need it anymore. Start over the easy way, and I'm going to delete these so that we rebuild them. Okay, so it said we're going to read integers from a file called integer.txt. I already have the fstream. There it is. Include fstream. So what's the command that I need to read files? Ifstream. Ifstream. R-E-K-M. And then I need to decide what my command name is going to be, something similar to cin. I like read. It can be anything that's not already a predefined command in C. Read is not. So it can be read. Parenthesis. Quote. Then we give it the file name. And the direction said the file name was called integer.txt. And again, that's on my memory stick. So e:/integers.txt. Comma. Double colon. No. iOS double colon in. That's an input string. All right, so there's our input command. And then it says we're going to write to a file called product.txt. So what do I need to write? Offstream. And again, this is going to be a command similar to cout. What would we like to call it? Read and write. What did you say? Display. Display. Write would have been a good choice. Read and write. All right. Similar notation. Quote. e:/. It says we're writing to product.txt, comma, iOS, double colon, out. All right. So there's our input and output streams. All right, so we're going to be reading in some integers, and we're going to find the product. So what do I need?
Variables.
Variables. It sounds like they're integer variables because it says we're going to read integers. So what do we want to call it? Number? Product. Good? Now, here's the bad news. They didn't tell us how many numbers we're reading. It can be any amount. Might be 1, might be 1,000. We have no idea how many numbers we're going to read. So what do we do?
See out instructions.
Yeah, instructions. See out instructions. Distractions.
That wasn't on.
All right, I'm not going to write all the instructions this time. No, I will put an end line. I mean, the instructions would basically say, this is going to read integers.txt and output their product to a file called product.txt. I was lazy, didn't feel like typing all that. All right, so the big question is, how do we tell the computer to read when we don't know how many things there are to read? It might not be an end line, though, because remember that it could go across and it could go down to the next line and across. There might be 100 lines of data. It will? Maybe. All right, so here's what we do. We're going to try reading the first one. So we're going to read number. So we're going to try to read in the first one. And again, read now. Read is the command we created. It works just like cin. And then we're going to do a while loop, and we're going to tell it to keep reading as long as you can. And here's the command you use. While, parenthesis, not read dot fail. So you remember the other day we were trying what if we had bad data and I said that the command was cin.fail? You can use the same command, read.fail. So that will read as long as it can. So it will read and read and read till either it gets to bad data. What would be bad data in this case? A character or a float. Those would both be bad data values. Or it will read until it gets to what's called the end of file, EOF. So in a file, there's an actual invisible that you can't see. That's a flag called end of file. So this will now read over and over and over again until it gets to the end of the file or until it hits some bad data. All right, so let's assume it read, and the first thing was actually good data. So it read a number, like 6. Once it reads in a good number, what do we want it to do?
We define product as 1, and then multiply number times product.
In fact, we better start product as 1. And then what we really want to do is keep a running total of the multiplication. So you're absolutely right. I should have gone up here and started product as 1. And then we want to say product times equals product.
Maybe product times equals
Yeah, number. Sure. It'd be easier to just multiply 1 by itself over and over and over again, but
if you want to crash the mean.
no, it wouldn't crash it. 1 times 1 times 1 times. The computer has no issue with it. Then what? Read the next number. So read number. All right, so what this is going to do is it's going to read. It's going to try to read the first number. If it reads a number, if it reads an integer, like it should, because this is an integer type variable, it will come into the while loop. It will do the multiplication for us, and then it will try to read the next number. And if the next number is an integer, then the read does not fail. The read is good. It will multiply and it will read again, and it will keep going as long as it reads an integer or until it gets to the end of the file. It will stop when it reads a bad character, which could be a float variable or a letter, if there's a letter in the data file, or it will stop when it gets to the end of the file. All right, so I think we've got it set up. So a little documentation here, read values, and compute product. That's what that loop is going to do. All right, so we read and we did all of our stuff. Now what should we do? We got to write to the file, so we should write the answer. Okay, so display the product is product. You want to see out it? You want to see it on the screen too? Otherwise, we're not going to know if anything happened. I'm not going to, just for fun. It's kind of weird when you don't do that. So it would print the instructions, and it just says press any key to continue. It doesn't output anything because we didn't tell it to. But let's look. Oops, I think I got to close this and reopen it to get it to refresh. It was there? Oh, it was on the right. There it is, product.txt. The product is 64,800.
How do we know that's right?
You don't trust me?
No. Curiosity. Oh.
All right, start multiplying.
We try to 3 times 5. That's 3 times 2. You got 5 times 2, 4.
All right, so notice my data is not set up very cleanly. This row has 4 numbers. This one has 3 numbers, and then your data can be messed up like that. It does not need to be written nice and neatly, left to right, across, clean. Oh, we got the right answer. Good. It was nice of me to only put like 10 numbers in there and not 1,000, right? Because then you would have been checking me for a while.
I mean, you could have just like loaded it up with ones and then just put a random number so you have to
I
search
could
for
have. But this points out a good thing, a good programming practice. What if somebody gave you a file like this and they asked you to compute the product, and the file had like 10,000 numbers in it?
Another file. Yeah, make it smaller.
Make a small file with a short number of numbers and test it on that to make sure you're getting the right answer, and then load up their file and run it on their file. That's a very good programming practice. When somebody gives you something big to deal with, test it on a small file to see if you're getting the right answer, and then you can assume your coding is right. Now, what if the teacher had done a bad thing and put a float right there?
Yeah, it might end at the period, because that's not a...
All right, just to speed stuff up, let's print it to the screen so we don't have to look at it every time. We don't have to open the file every time, so we'll do a CL.
You can do it online.
No.
Yes.
No one.
So it tells us the product is negative 60.
Okay. It reads -2.
So what happened is
It starts as a
it read the 2, it read the 3, it read the 5, it read the -2, then it tried to read that decimal, and it crashed. All right, so we're about out of time. Next time, we will continue with this program, so I'll bring this one back, and we'll talk about how do you fix it. We really want it to read till it gets to the end of the file, but it didn't. There's a bad character in our data. So next time we'll talk about how do you tell the user your data was corrupt so the user can go back and fix it. So we'll talk about that next time.